system. If we have a discrete time signal with impulse response h of n, and let's say output is y of n, we can take the Laplace transform, z transform on both sides, that is x of z, and let's say the z transform of this is h of z. Okay, and we can write h of z is y of z by x of z, and this is called the system function of that discrete time signal, a discrete time system, h of z. That is the this one. Okay, when we discuss this Laplace transform system analysis using Laplace transform, continuous time analysis of continuous time systems using Laplace transform, we discussed about the properties of that system. We can obtain that properties of that system from the ROC of that system function, isn't it? Can we do the same thing here? Suppose h of z is given, system function is given. Can we say something about the properties of the systems from the ROC of h of z? Suppose the system is causal. What should be the ROC? What should be the shape of the ROC for a causal system? If h of n is, this is the impulse response, it is a causal system, means what? What type of signal is that? H of n?
Right-sided.
Right-sided. Not only right-sided, it is causal means hn is 0 for n less than 0. Isn't it? It is a right-sided signal, but this condition is also, not all the right-sided signals are causal signals. Okay. Now tell me what is the shape of the ROC? What is the shape of ROC? If you are given ROC of the system function, can you determine whether it is a stable, whether it is a causal system or not? If it is a causal system, the ROC should be what? Is it outside a circle? That is for the right-sided signal. But if it is causal, what about this? Will it be in the ROC?
Yes, sir.
If it is a causal system, this will be in the ROC. So we can, in this case, unlike this is, we can differentiate between a causal system and a right-sided system, right-sided signal using this point. Okay, so this outside a circle, and this z equals to infinity is also in the ROC. Now, what about a stable system? Stable system. Stable system means what? This is the condition for stability. The impulse response is absolutely summable. What does it mean? Which point is in the ROC? What does it mean? What is the condition for if you consider any signal? What is the condition if you consider any point here? Let's say this distance is r. What is the condition for existence of Z transform at this point? Is it this? That is the condition for existence of Z transform. This is R. Now tell me what does it mean? If the system is stable, this is absolutely integrable, absolutely summable. So can we say that this is in the ROC? What is that? That is called It is called the unit circle. Unit circle is the circle of radius 1. So if the system is stable, the unit circle is in the ROC. Okay. Now, last property, if a system is causal, both causal and stable, can we say something about the location of the poles for a causal and stable system? But
Magnitude of poles is less than 1.
magnitude of poles less than 1. So can we say that if the system is causal and stable, all the poles must be inside? If there is a pole, that must be inside the unit circle. There should not be any pole outside the unit circle. Is it true?
Yes, sir.
That is a property. Okay. For a in the case of Laplace transform, it was what was the corresponding property? All the poles must be on the left half of the S-plane. But here, all the poles must be inside the unit circle. Okay.
So could you explain the unit circle part again? Like how
Unit
did we
circle.
get it from?
This one, unit circle part.
Yes, sir.
No, because this is the condition for stability, isn't it?
Yes, sir.
So what is the condition for existence of Z transform at this system function? Let's say at some point Z naught. What is the condition for existence of that Z transform at that point? Let's say this is R naught. Is this the condition? This should be finite. Okay. And if it is given that this is finite, does it imply that R naught equals to 1? This is in the ROC?
Yes, sir.
Okay. That is the importance of unit circle. Okay.
Yes, sir. Got it.
Okay.
Sir, invertibility using this system
Yeah,
function?
invertibility also the property. I didn't explain it because it is similar. Like H inverse means you can find the inverse of that system function. Poles will become zeros and zeros will become poles. Okay, it is 1 upon Hz. Then you can find the corresponding properties easily.
Yes.
Okay.